All right, welcome to our lesson video for day 5.2, Unit 5, Day 2. We're going to be talking about special right triangles. Okay, and I'll explain kind of why we call these special right triangles in just a moment. These are the two kinds of special right triangles we're going to be dealing with today. We have what's called a 45-45-90 and a 30-60-90, and I'm going to explain to you where we get those before we get going very far with the video. So the first thing I want you to do is kind of just watch and pay attention. You don't need to write anything down, just make sure you're listening to the video. I want to say that let's start with a square. Okay, a square is a quadrilateral where all four sides are congruent and all four angles are right angles. Okay, all right, so all four angles are right angles. But if we were to take this and kind of manipulate it and change it, I'm going to show you where we get our first of these special right triangles. If I were to fold this square along the diagonal, okay, like this, okay, fold it along the diagonal like this, I get a right triangle. Okay, and this right triangle is what we call a 45-45-90 because that describes the three angles of this right triangle now. We have our right angle from the square, which was a 90 degree, but I took each of these right angles at the end of this diagonal and I cut each of those in half to fold it. And half of 90 is 45. Okay. Now, since these angles are both congruent 45-degree angles, that creates congruent sides here and here. Okay, and we know those are congruent because they're sides of a square. And so that creates this relationship and leads us into our next figure. All right, and so let's talk a little bit about a 45-45-90 triangle. All right, each of these legs are the same as each other, and so I'm going to actually start by identifying each leg. I'm going to call each leg X. Okay, each leg is some value X. And if we were to work through the Pythagorean theorem using our algebra skills, we would discover that what happens is this hypotenuse ends up being a length of whatever X is times the square root of 2. Now in class, I'm going to further explain where we get that, but this is one of the things you're just going to have to memorize for this. And so when we work with 45-45-90 triangles, each of the legs are congruent, they're the x's, and the hypotenuse is always root 2 times whatever the leg length is. So we take whatever this leg length is and we multiply it by root 2 and we get our answer. Okay, so we're going to do some examples. Okay, for number 1, we are given that one leg of your 45-45-90 triangle is 8. Now they didn't write the other 45, but we know that they're both going to be the same because 90 plus 45, when I subtract those from 180, I get 45 for the other side, or other angle. So that this side is 8, the other leg is also 8. So I know right away that the value of X is just 8. There's no math really to do. We're just using the fact that both legs are the same as each other. Okay, so X has to equal 8. This Y value represents our hypotenuse. Remember, the hypotenuse is always whatever the leg length is, in this case 8, times square root of 2. So we just put 8 square root of 2 there. Okay? Same idea on number 2. We have a 45-45-90 special right triangle. Y is one of the legs, X is the hypotenuse. Well, this is your other leg. So to find X, we take our leg length and we put a square root of 2 after it. We're actually multiplying by the square root of 2. But we're writing this in what is called simplest radical form. We're not actually doing the square root of 2 with a calculator and getting a decimal before we multiply by 25. And of course, the other leg value Y is also just 25. Okay, now before we do number 3, I want you to change the number. This is not going to work out real well for us, so we're going to change this number. Instead of 19, I want you to call this hypotenuse the square root of 10. Okay, and you'll understand maybe why I changed it after we work with this. But we're going to call this hypotenuse the square root of 10. Well, each of the legs are congruent. So whatever I get for X, that's going to be Y. But you need to understand on this one, we're working backwards because I've given you this hypotenuse, but it is in terms of 10. So whatever X was times the square root of 2 ended up equaling the square root of 10. Well, to figure out what X is, we have to solve for X by dividing by the square root of 2. Now, you'll remember that we talked about in class, when I divide radicals, I can just divide the numbers. 10 divided by 2 is 5. And keep that under the square root. So x and y are both the square root of 5. Okay? And that is our first example of a special right triangle. But then we have another kind of special right triangle called a 30, 60, 90. And I'll explain why we have those angle measures in just a moment. So if we started this time with what we call an equilateral triangle. Last time we started with an equilateral quadrilateral, or a square. But now we're going to use a triangle where all the sides are the same. If I were to take this triangle and fold it in half, okay, like this, okay, we get another right angle. Because when folding it exactly in half, we fold it in half like this. Now, if you remember from last semester, in an equilateral triangle, all of the angle measures are 60 degrees. But when I fold this in half, this angle that was 60 up here, I now have half of that, or 30. This angle folded right on top of the other one, so it is still 60. And this is now a right angle, 90 degrees. So that's where we get our 30, 60, and 90 to label this triangle. And so we want to look at the relationship of side lengths, okay? Now, because this is not an equilateral triangle anymore, and because it is not an isosceles triangle, they have different side lengths. This is a scalene triangle. So we have two different leg lengths. We have what's called the shorter leg and the longer leg. We're always going to start with our shorter leg here. Okay, everything's going to be based on what the shorter leg is. So I'm just going to call that shorter leg x, which means that I have some expressions for the longer leg and hypotenuse using x. And I'm going to show you the hypotenuse first. Remember that to get my 30, 60, 90 triangle, I took an equilateral triangle and folded it in half. When it was an equilateral triangle, all three sides were the same. So this bottom side is the same as this side on the right. Well, when I fold that bottom side in half, it's now half of that full side. Well, x would have to be half of 2x then for that hypotenuse. Okay, so if this is x, this side is 2x. And then I could use Pythagorean theorem again, and I'll show you this in class, but what we end up getting for our longer leg is that it is whatever this short leg is times the square root of 3. And don't worry about where that 3 comes from right now. I'll demonstrate that in class, but this is what you have to memorize for 30, 60, 90 triangles. Remember that the shorter leg is always opposite the 30-degree angle, but you should be able to tell which of the legs is shorter from however the picture is drawn. So we're going to try some examples with this. So on example 4, we are given this leg length of 5. It is right between the right angle and 60-degree angle, and you can tell that's shorter than this other leg x, so this is the short leg. So the short leg is my starting point. The hypotenuse would be your y value, and then your x is your long leg. Well, the hypotenuse is always twice that short leg. So I'm going to do 5 times 2, which is 10. So my hypotenuse y is 10. And the long leg here is always short leg times root 3. So it's going to be 5 times square root of 3. And that's what x is. And we leave it written that way. I could take the square root of 3 in my calculator and get a decimal and multiply by 5 and get an actual length here. But for special right triangles, we're going to leave these in simplest form. Okay? I want you to pause the video and try and come up with your answers for number 5. Okay, if you need more time, go ahead and keep the video paused. Otherwise, this is the answer you should get. X is the hypotenuse, so it's twice as long as the short leg. This 14 is your short leg. So I'm going to do 14 times 2, which is 28. And your y value is your long leg, so I'm going to do 14 times the square root of 3. And that is my long leg. Okay, we're going to take a look at number 6 now. To do number 6, notice you are not given the short leg. This is the hypotenuse. The short leg is x. Since I'm given the hypotenuse, to go backwards to the short leg, you need to realize that whatever the short leg was x was multiplied by 2 to equal this 32. And so we can kind of set it up as an equation and divide by 2 on both sides now to get that x is 16. Well, that is going to help me find the longer leg by just multiplying 16 by the square root of 3 to get 16 root 3. Okay, and those are the only examples from this page of the notes that we're going to do. We'll do some other examples in class later, but that's just a basic introduction to what we call special right triangles. I do want you to go ahead and turn to this next page where we have multi-step special right triangles that we're going to work with. And all we're really going to do is break this down into 2 parts. Okay, so to do number 1, to find the missing side length here, they want to find the value of x. We're going to need to understand what the other information has given me. So before I can find x, that is the hypotenuse of a 45, 45, 90 triangle. I don't have any of the other side lengths. So I need another side length. Well, this side length of your 45, 45, 90 is directly connected to this 30, 60, 90. Okay, I know this is 30 degrees because 60 plus 90 plus 30 would equal 180. And that makes this the short leg of that 30, 60, 90. Remember that in a 30, 60, 90, the short leg times 2 equals the hypotenuse. Okay, so this is 6 times 2, which is 12. But that 12 is also the leg length of your 45, 45, 90 triangle. And the hypotenuse of a 45, 45, 90 triangle is always the leg length times the square root of 2. Okay, so triangle 1 was your 30, 60, 90. Didn't draw that very well. And we used this by doing 6 times 2 to get that 12. Triangle 2 then was your 45, 45, 90 triangle. To find x, we realized that was our 12, so x was 12 times the square root of 2. All right, we're going to do another one of these examples in class, but just wanted to give you an example where you have to combine your knowledge of both kinds of triangles to find your answers.